Hello students, welcome to my channel CM Hub where you, me and chemistry connect with each other. This platform is a gateway for mastering chemistry. Welcome back to another interesting episode based on the question that was asked in IIT Advanced 2024 paper 2. Now this again is a question corresponding to the states of matter. Like we have done in the earlier episodes, let us first read the question, understand the question, know the concept behind it, and then solve the problem. A closed vessel contains 10 grams of an ideal gas X at 300 Kelvin, which exerts to atmosphere pressure. At the same temperature, 80 grams of another ideal gas Y is added to it and the pressure becomes 6 atmospheres. The ratio of root mean square velocities of X and Y at 300 Kelvin is. Unlike the previous episode where we learnt about the concepts involving nuclear chemistry and states of matter, this is purely states of matter. This is not that tricky as we think. Only thing is you need to know what substitutions have to be done and how to convert that RMS velocity in terms of the given data. Let us first understand what is given. You are given 10 grams of an ideal gas. So initial weight that you are given is 10 grams. Temperature is 300 Kelvin at both the conditions. So temperature remains constant. Closed vessel, so volume also remains constant. But you are not given the molecular weight. You are just given an ideal gas. You don't know the molecular weight. The second is 80 grams of another ideal gas. So W2 is equal to 80 grams. Here too you are mentioned as another ideal gas. Even its molecular weight is not given. But the initial pressure that was present, P1 is equal to 2 atmospheres. Now what is P2? P2 here cannot be 6 atmospheres because 6 atmospheres is the pressure that is observed after addition of 80 grams to the 10 grams of the first gas. 10 grams was already exerting 2 atmospheres. After addition of 80 grams, the final pressure became 6 atmospheres. That implies the additional pressure that is because of the second gas is only 4 atmospheres. Apply the Dalton's law of partial pressures. P total is equal to P1 plus P2. When two gases which do not mix with each other are taken in a vessel, then the total pressure exerted is equal to the sum of the individual pressures exerted over the same volume and at the same temperature. So initial with respect to first gas is 2 atmospheres. I don't know what is the second gas, but the total pressure is 6. So what is X equal to? X is equal to 6 minus 2, that is equal to 4 atmospheres. That is what we have written. So generally students make a mistake. They take P2 as 6 atmospheres. It is not 6 atmospheres. It is only 4 atmospheres. So now I know W1, I know P1, I know W2, I know P2. But he is not asking any relationship between pressure and weight or pressure and volume or pressure and temperature. He is asking us the ratios of the RMS velocities. Now let us first understand again what RMS velocity is. RMS velocity is root mean square velocity. How do we define RMS velocity as? It is defined as the square root of the mean of the squares of the individual velocities in a given sample of gas. This is the formula that we need to apply when you know the number of molecules present in a given sample of gas and the individual velocities possessed by them. There is another equation for RMS velocity. RMS velocity is equal to under root 3 RT by M, or we go for it as under root 3 PV by M, or this is equal to under root 3 P by D. So these are the three representations of the RMS velocity, of which I take one such equation. RMS velocity is equal to under root 3 RT by M and use this equation. Sir, The problem is with respect to pressure and weight. Now there is no pressure at all involved in this. How will you approach this, sir? Here I use the concept of PV is equal to nRT, or PV is equal to number of moles is equal to weight by molecular weight into RT. See, different lecturers come with different approaches. IIT Advanced itself is one such methodology to find out the different approaches. Now here you are given objective based question. Earlier it was a subjective based question. So different approaches were analyzed. So now what I do is here I find out the M equation, where M represents the molecular weight. M is equal to WRT by PV. So now in place of M, can I substitute WRT by PV? So RMS velocity is equal to under root 3RT by WRT by PV. So what will you get? I rewrite again here. RMS velocity is equal to under root 3RT by WRT by PV. In place of M, I have substituted WRT by PV. So now this is equal to RT. RT gets cancelled. This becomes 3PV by W. Now I put RMS velocity of first one R1 as equal to under root 3P1 V1 by W1. R2 of the second gas is equal to under root 3P2 V2 by W2. So now using these two equations, because he is asking us to find the ratios of RMS velocities, R1 by R2 is equal to under root 3 P1 V1 by W1 into this becomes W2 by 3 P2 V2. 3 cancels. V1 V2 gets cancelled because it's a closed vessel, volume remains same. So you get R1 by R2 is equal to under root P1 W2 by P2 W1. Now look at the equation. We started with 3RT by M, but we got the ratios of RMS velocities in terms of the pressure and weight which are given for us. Now let us find out R1 by R2. What is R1 by R2? Let us write the formula again. It becomes P1 W2 by P2 W1. So what is the initial pressure? 2 atmospheres. What is the weight of second gas? 80 grams. What is the pressure of the second gas? The pressure of second gas is 4 atmospheres. What is the weight of the first gas? 10 grams. So this one goes off, 4 2s. You get under root 4 by 1. What is under root 4 by 1? 2 by 1. So what is the ratio of RMS velocities of first gas to second gas? 2:1. Students, teachers will come with different approaches. I would suggest that if your concepts are right, your approach can take any path. Believe in yourself, believe in the concepts that you have learned, and concepts alone will make you the winner. We'll see you again in another interesting episode with another interesting question and concept behind it. Till then, take care. Bye-bye.